This is Chemistry's Experiment 10. It is on page 214 of your chemistry textbook and workbook. The aim of this experiment is to investigate the influence of concentration on the rate of the reaction between vinegar and baking soda. Our investigative question is, what is the relationship between the concentration of an acetic acid solution and the rate at which it reacts with baking soda at constant temperature? And our hypothesis is, if the concentration of the acetic acid solution is increased, while the temperature of the reaction system and the concentration of the baking soda solution remain constant, the rate at which the reaction occurs will increase. Our variables are: our independent variable, which is changed, is the concentration of the acetic acid solution. The dependent variable, which is measured, is the time elapsed. The controlled variables, which remain the same, are the temperature of the acetic acid solution when the reaction starts, the concentration of the baking soda solution, the number of soap drops, the diameter of the measuring cylinder, and the type of measuring cylinder used. Is it glass or plastic? You are going to need the following apparatus: a 500 cubic centimeter measuring cylinder, a 50 cubic centimeter measuring cylinder, a 60 cubic centimeter syringe, 3 small glass beakers, an electronic scale or triple beam balance, a spatula, a glass stirring rod, a thermometer, household vinegar, baking soda, dishwashing liquid, a medicine dropper, a stopwatch, and a plastic tray. A quick fact to keep in mind while doing this experiment is that the pure ethanoic acid or acetic acid is extremely corrosive. It will burn through your skin, mix with bodily fluids, and cause severe pain. And here is a tip to help you with this experiment. Because it is difficult to determine when the reaction is complete, we can add a drop of dishwashing liquid to the vinegar before the baking soda is added. The released carbon dioxide gas will cause the dishwashing liquid to bubble up. If the reaction occurs in a measuring cylinder, the elapsed time from the addition of the baking soda until the foam reaches a certain height or volume in the measuring cylinder can be used as a measure of the rate of the reaction. And here are some warnings that you have to keep in mind. Do not inject the baking soda into the measuring cylinder too fast. The foam that forms then will not necessarily be due to the reaction. Do not stir the mixture while it is reacting. The bubbles will burst. And do not use the thermometer to stir anything because it breaks easily.
The method for this experiment is as follows. Measure 60 cubic centimeters of vinegar in a measuring cylinder. Add 1 drop dishwashing liquid with a medicine dropper and carefully stir. Determine the temperature of the vinegar precisely. Weigh 1 gram of baking soda in the glass beaker. Add 25 cubic centimeters of water to the baking soda and stir to dissolve the baking soda. Use the plastic syringe to draw up 20 cubic centimeters of the baking soda solution. Start the stopwatch when the baking soda solution is added to the vinegar in the large measuring cylinder. Determine the time it takes the foam that forms to reach the 100 cubic centimeter mark. Determine the temperature of the final mixture as soon as the foam reaches the 100 cubic centimeter mark. Write down the change in the temperature. Repeat the experiment twice more. Change the concentration of the vinegar by adding different amounts of water. Let us complete the table for the following readings. The volume vinegar used was 60 cubic centimeters. The volume water is 0 cubic centimeters. The volume vinegar solution is 60 cubic centimeters. The concentration of the baking soda is 40 grams per cubic decimeter. The volume baking soda solution used was 20 cubic centimeters. The change in temperature was 1 degree Celsius and the average time elapsed was 2,68 seconds. Complete the rest of the table by yourself using different concentrations of the vinegar solution. The results are as follow. The vinegar and baking soda react according to the following equation. CH3COOH plus NaHCO3 produces CH3COONa plus CO2 plus H2O. The concentrated vinegar contains more vinegar particles that can react with the baking soda and cause more effective collisions per second. The rate of the reaction is therefore greater. The vinegar and baking soda react to produce CO2 gas and the solution fizzes. Due to the carbon dioxide, the dishwashing liquid foams. The more CO2 released per second, the more foam forms per second. The foam pushes up faster in the measuring cylinder if the rate is greater.
Our conclusion is, the hypothesis was correct. If the concentration of a reactant solution is increased, the rate of the reaction increases since there are more effective collisions per second that can occur. Wow.